Hello and welcome back to the Aquifer. My name is Ted Bennett. I'm a civil engineer, but I'm not just any civil engineer. I actually specialize in the evaluation, design, and construction of pump stations. And specifically, I found my expertise in wastewater pump stations. In this segment, I'm going to give you some thoughts on permanent backup pump systems for wastewater infrastructure. I've heard a lot about these systems at conferences and read about them in trade materials, but I've not yet worked on a project where such a unit was considered. I was very interested in this concept, and so I did a little bit of research and made a site visit, which I'll explain to you. In this video, I'll talk to you about what this concept does for your collection system and why it's something you might wish to consider. I'll talk about the advantages and explain some limitations and challenges that an installation may experience. Then I'll compare it with conventional backup generators or other pumping concepts that you might wish to use alternative to a permanent backup pump station. And finally, I'll give you some pointers for successful installation based on my assessment. I put together this segment in response to some feedback from my LinkedIn followers who inquired asking if I would give my thoughts on permanent backup pumping concepts. I really appreciated the positive feedback, and I prepared this to answer some of those questions. So you might ask, what is a permanent backup pump station? Well, it is a permanent pump that is placed generally above grade to back up an existing pump station and to make sure that water can be pumped around the station no matter what's happening in the pump station. So basically, a backup pump station springs into action to maintain flow around the pump station if the regular pumps or controls fail to activate to draw water out of the wet well. The key here is that we're achieving continuous pumping no matter what the conditions are. So when might it be used? Well, the unit could be put into service during a power failure or a pump failure. But realistically, a backup pump could be used during pump maintenance as well. The goal here is peace of mind and to keep the sewage flowing and keep it from backing up into the upstream collection system or possibly someone's basement, which is definitely an emergency in my book. So like I said, peace of mind. With any backup system, it's like a spare tire. It's there to provide that peace of mind that a backup plan is in place, a plan B. 10 state standards governs wastewater design in the area where these pump stations were located in Ohio. 10 state standards for wastewater requires that agencies have some form of backup in either two electric sources, a portable or permanent generator, permanent pumps like these, or portable pumps. Okay, so how does it work? To help me show you how it works, here's a diagram. It shows the basics. In this arrangement, the permanent backup pump is backing up a submersible pump station. And generally, these submersible pump stations are what we call a duplex station, where there's two pumps in the pit. But technically, a backup pump system could be used with a variety of pump station types, so long as the suction pipe can extend down to the water level. In this setup, the submersible pumps are located in what we call a wet well. The backup pump is located above grade, and in this case, inside a sound attenuated enclosure powered by a diesel motor. And normally, the submersible pumps will draw down and pump out water that is drained into the wet well from the upstream sewers. However, things can happen at every pump station, and eventually something will happen. The pumps will fail to start for one reason or another. And this is when the real stressful situations can happen real fast. And this is where the backup emergency pumping capabilities that 10 states requires agencies to have are needed. When the pump fails to start, the backup pump activates when the water reaches a high level flow. The backup pump runs until the wastewater in the wet well reaches the off level. And this cycle continues until an operator is able to visit the site and understand why the regular pumps are not pumping properly. Now here's an exterior shot of the permanent unit with the enclosure shown. These are the suction and discharge pipes, with the suction pipe coming out of the ground and the discharge pipe appearing to go back into the ground. And take note of the insulation over the discharge pipe to prevent freezing. These pipes are ultimately designed to drain back to the wet well, but I think the insulation is provided as a measure of protection against freezing. Here's a closer look at the pump and motor skid that's inside the enclosure. There's also a human-machine interface behind the cabinet doors to permit the operator to see how the pump is operating. And as you can see, if you're familiar with generators, this looks very similar. Now this slide shows the discharge piping from the backup pump, and the check valve and the connection to the force main. You can see the check valve and the normal pump discharge piping that we'd see at a conventional submersible pump station down below the backup pumping. And this setup was constructed as part of the original pump station construction, but this could be easily retrofitted to an existing station. For my investigation and assessment, I visited 2 sites, one located in southeastern Ohio and one located in central Ohio. One of the pump stations served a subdivision and the other one served an area with very, very shallow basements. I could see a home across the street with a basement elevation that was not much above the influent sewer elevation at the site with shallow basements. If that particular station had gone down, flooding of that basement would probably occur pretty quickly. These units were both Flight Godwin units dating from roughly 8 or 9 years ago, and both units were rated at roughly 50 horsepower, and they were both backing up submersible pump stations like the diagram that I just showed you. I asked the operators about a typical operation and maintenance of the systems, and the operators of each system explained they normally did a manual operation of the backup pump system. They simply shut the regular pumps down, and the shallow sewer system was run about once a week through an entire cycle, and the other unit was run through 2 cycles every 90 days. The oil is then changed roughly every 2 years, and it was recommended by one of the operators that an agency would want to keep a head gasket and a drive belt on site, as these seem to be typical repair items. So the primary feature or benefit of a backup pump concept is to provide pumping capability that is powered by an alternate power source. For the units I observed, power was supplied by a diesel fuel-powered motor. The operators did mention that the Xylem units that they had were quieter than the Thompson units that they had elsewhere in their system. And realistically, the number one benefit that you should take away from the backup pump system is the ability of the backup system to function without a control panel. A control panel is what tells the regular pumps when it's time to turn on and turn off. It's basically the brains of the operation. If a control panel is lost to a station that has a generator, there's still no protection against control panel failure, which happens commonly enough. A common cause of control panel failure loss is lighting strike, but I've also seen vehicles smoke control panels too in car accidents. Either way, if the panel is lost, the agency still must bring out some kind of backup pump if they're using a generator to operate the station, because without the control panel, there's no information to tell the pumps when to turn on and turn off. The backup pumps concept, however, runs no matter what happens with the control panel, because it basically turns on and off using floats. These are independent of any control panel. One float is placed high to turn the pump station on, and one is placed low to turn the pump station off. From what I gathered in my assessment, the most critical design consideration for backup pump setups is related to the ability of the backup pump to prime. Centrifugal pumps are limited to drawing suction a maximum height of roughly 20 feet, and this is because of a concept called net positive suction head, which we refer to as NPSH for short. Basically, NPSH involves the fact that a pump creates an area of no pressure, called a vacuum, at its center line. Since the pressure in the pump is zero, it is air pressure that is on top of the water in the wet well that drives water into the low pressure pump. The challenge is that air pressure pushes down with a force of maybe only 30 feet of water, and there's always frictional losses in the pipe. And so in the real world, you don't want to get too close to the maximum lift. I've seen challenges in my own career of trying to draw suction too high. So the height of the water that can be drawn into the pump limits the ability of these pumps to be used in deeper stations, perhaps deeper than 20 feet. And realistically, I think this is why I've not seen this type of unit used on one of my projects, because I do very few pump stations that are shallower than 20 feet. In addition to the net positive suction head concern, our tour guides both mentioned issues with rigid piping used to drain lines running back to the wet well. They recommended flexible connectors be used for the drain pipe to avoid cracking caused by freeze-thaw thrust in the ground. There was also a concern with pipe freezing during extreme cold weather, so automatic drains are built into the units, and those units that are draining must function properly. But the most troubling challenge was that both operators warned that the floats were the most likely part to fail in their system. This concern gives me some more pause that I'll talk about later. As far as comparing the permanent backup pump with other options for backup, I've done a basic comparison and contrast with the most common backup pump capabilities I see. And the most common concepts I see provided for conformance with 10-state standards is either the portable pump or the portable permanent generator. My overall assessment of the backup pumping concept is that the backup pumping setup is very similar to a permanent generator. It's an on-site piece of equipment that operates in an emergency. Having the backup pump on site is probably superior to a portable unit because ideally it's already on site and ready to go, similar to the generator. The sound generated by backup pumping units is basically what I would have expected to have heard from a generator. The sound attenuated enclosure appears to be basically the same thing as what a generator would be provided with. And this makes sense, since both the generator and the backup pump are powered by diesel motors. I have obtained some cost information from a supplier for the backup pumping setups, and the cost is comparable to that of a backup generator of similar capacity. The enclosures were covered with some mold and mildew and probably could use a good power wash to keep them looking new. The biggest takeaway for me was reliability. One of the units was out of service awaiting repair of a head gasket, and the other unit I inspected failed to turn on due to a power supply problem with the fuel pump. And when that unit did turn on, the low float had failed and the backup pump did not turn off. The operator had to manually shut the system down. So here are a few recommendations that I developed for successful application and operation of one of these backup units. The first one is to make sure the setup is appropriate for the priming capabilities and that NPSH requirements would not unduly or surcharge or risk the upstream collection system. Overall, the backup pump is basically equivalent with a generator. The key determining factor between a permanent generator and a permanent pump would be the depth of the pump station and an acceptable water level upstream relative to NPSH. Additionally, I feel the best way to make sure that the pumps are ready to operate as the backup is to regularly test the system. This can be done manually by a crew shutting off the pumps, as was explained to us in our site visits, or killing the power to the pump station. I'm curious if this can be programmed to happen automatically using some logic in the pump control panel. This would be like the weekly operation of most generators that we see placed at pump stations. I felt like more regular operation of the units that I observed would be a good step towards improving the overall reliability. And my last recommendation would be to use some technology besides floats for the backup pumping system's on or off control. This would be my number two step towards improving the reliability. But ideally, this would be some kind of analog type signal so you could avoid the need for a control panel, which is a key benefit of the backup pumping system. So overall, permanent backup pumping is a feasible way to provide that emergency operating capability. But like anything else, there's typical challenges. The reliability of the concept could be improved slightly using the recommendations that I noted. But overall, I think this is a reasonable way to achieve the emergency pumping capabilities. So I hope you found my assessment of the permanent backup concept informative. I certainly learned a little bit about this concept, making my investigation and preparing these thoughts for you here. And thank you again, as always, for supporting my YouTube channel, The Aquifer. I look forward to hearing some feedback from you all on this, and feel free to reach out to me here or on LinkedIn. Hey, thanks for watching and have a great day.